So today I'm going to talk about the different types of organic compounds. So when dealing with organic chemistry and hydrocarbons, you'll come across the functional groups. That is when hydrocarbons undergo some sort of change and they become different organic compounds with unique properties. So today I'm just going to go over some of the common ones. And first, let's start with alcohol. That is when a hydrogen is replaced with an OH, hydroxide. So here we have a hydrocarbon group, and instead of a hydrogen, we have a hydroxide right there, or hydroxyl group as they call it. Next we have an ether, which is when an oxygen is in the center of two hydrocarbon groups. And as you can see, the oxygen is in the center of both hydrocarbon groups. Next, we have a halocarbon, which might sound familiar because it kind of sounds like halogen. That is when a hydrocarbon group is attached to a halogen. That makes sense, right? So we have a hydrocarbon group attached to X, which could be chlorine, fluorine, bromine, or any other halogen that there is. And next we have amine, which is simple. It's just when a hydrocarbon group is attached to NH2. And next we have aldehydes, which is when a carbon to oxygen double bond with at least one hydrogen is attached at the end of a hydrocarbon chain. And as you can see, you have a carbon to oxygen double bond with at least one hydrogen. This is just an example. And it's attached at the end of this hydrocarbon chain. That's where it's the beginning and this is the end. Alright, next we have ketones. We have ketones, and that is kind of similar to aldehydes, a little bit different. It's when a carbon to oxygen double bond is in the middle of the chain and it's surrounded by carbon. So here it's surrounded by a carbon group here and surrounded by a carbon group here. So this would be the end, the beginning, and you see it's in the middle. Next we have a carboxylic acid. And that is when you have this sequence right here where you have a carbon to oxygen double bond. The oxygen and the hydrogen is bonded at the end of a chain. So here we have, pretend there's bond, bond, bond here. And this is a hydrocarbon group, and this would be at the end of the chain. So next we have an ester, a carboxylic acid group in the middle of the chain. So instead of up here where we had this at the end, we have it in the middle. So we have a carbon group right here, and then we have this chain right here. And this is the end of the group. And now I have an example for you. For example, root beer hasn't tasted the same since sassafras oil was outlawed because of saffron oil. It causes cancer in rats and mice. And the problem is to identify the functional groups of saffron oil. So here I've drawn this. Let me draw it again. So you have CH right here, and you have it double bonded to CH2, and you have a carbon chain here, and a pentagon. So there's a double bond there, and then there's a double bond there. So then up here we have 1, 2 to this O, to CH2, to an O, and down again. So the question is, what kind of functional groups are happening in this structure, which is saffron oil, which is very dangerous because it causes cancer in mice and rats. It's horrible. And they used to drink it in root beer. Anyways, so what you want to think about is think of all the functional groups that we went over and see which one applies right here. So immediately I can see that, hey, there's a double bond right here. So what does that mean? That means there's an alkene right here.